Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive tutorial on implementing refresh tokens with the .NET 6 Web API. This will cover the concepts, setup, code examples, and important considerations for security and best practices. Understanding refresh tokens. The problem: short-lived access tokens. In a typical authentication flow, like OAuth 2.0, a client application receives an access token after the user authenticates. Access tokens are designed to be short-lived, example 5 minutes, 15 minutes, or 1 hour. This limits the impact of a stolen access token. However, constantly prompting the user to re-authenticate for every short-lived access token is a terrible user experience. The solution: refresh tokens. Refresh tokens are long-lived credentials that are used only to obtain new access tokens. They are stored more securely and used by the client in the background, or with minimal user interaction, to get fresh access tokens. The flow. 1. Authentication. The user authenticates, example enters username/password. 2. Token issuance. The server issues both an access token, short-lived, and a refresh token, long-lived. 3. API access. The client uses the access token to access protected API resources. 4. Token expiration. The access token expires. 5. Refresh token request. The client uses the refresh token to request a new access token. 6. Token refresh. The server validates the refresh token, issues a new access token, and possibly a new refresh token, and revokes the old refresh token, best practice. 7. Repeat. The client continues to use the new access token to access the API. Benefits. Improved security. Short-lived access tokens minimize the damage if compromised. Better user experience. Users are not constantly prompted to re-authenticate. Revocation. Refresh tokens can be revoked, effectively logging a user out of all devices. Security considerations. When a refresh token is used, you should invalidate it so that it can only be used once. This prevents attacks where someone could keep sending it multiple times to get multiple refresh tokens and access tokens. 2. Project setup, Visual Studio or .NET CLI. 1. Create a new ASP.NET Core Web API project. 2. Install necessary NuGet packages. Microsoft.ASP.NET Core.Authentication.jwt for JWT authentication. Microsoft.Entity Framework Core.InMemory for an in-memory database, for demonstration purposes. You would use a real database, SQL Server, PostgreSQL, etc., in a production environment. Microsoft.IdentityModel.Tokens, core library for working with tokens. System.IdentityModel.Tokens.jwt, for handling JWTs. 3. Data model and database context. We'll use a simple in-memory database to store user information and refresh tokens. 1. Create a models folder. Add a new folder named models to your project. 2. Create user.cs*. 3. Create refresh token.cs*. 4. Create data context.cs*. 5. Register the data context in program.cs*. 4. Authentication service. This is where the token generation and refresh logic resides. 1. Create an authentication service.cs file, or similar name. You might want to create an IS authentication service interface as well for dependency injection. 2. Register authentication service and IHTTP context accessor in program.cs*. authentication and token endpoints, controller. 1. Create an authentication controller.cs*. 6. Configuration. 1. App settings.json*, add a JWT settings section. Secret key critical this must be a strong, randomly generated key. Do not use this example key in production. Store it securely, example in environment variables or Azure Key Vault. Issuer the entity that issued the token. Audience the intended recipient of the token, your client application. Expiry minutes how long, in minutes, the access token is valid. This should be relatively short. 7. Testing the API. 1. Run the application start your web API project. 2. Use a tool like Postman or Swagger UI register send a post request to /API/authentication/register with a username and password. Authenticate send a post request to /API/authentication/authenticate with the registered username and password. You should receive an access token and a refresh token. Access protected resource, not implemented yet. If you had a secured endpoint, decorated with authorize, you would include the access token in the authorization header, example bearer your _access _token. Refresh token send a post request to /API/authentication/refresh token with the refresh token. You should receive a new access token and a new refresh token. Validate try using the old refresh token again. It should be invalidated, and you should get an error. 8. Important security considerations and best practices. Secure storage of refresh tokens encryption encrypt refresh tokens at rest in the database. Hardware security modules, HSMs for high security applications, consider storing encryption keys in HSMs. Refresh token rotation rotate the refresh token every time it's used. This means issuing a new refresh token along with the new access token and invalidating the old refresh token. This helps to mitigate the risk of a compromised refresh token being used repeatedly. The code above implements rotation. Refresh token expiration set an expiration time for refresh tokens, but make it longer than access tokens. A reasonable expiration time might be a few weeks or months. Refresh token revocation implement a mechanism to revoke refresh tokens, example if a user changes their password, logs out, or if suspicious activity is detected. Store revoked refresh tokens in a blacklist, or mark them as revoked in the database. Check the blacklist during refresh token validation. The above code implements a simple revocation mechanism. IP address binding more complex, but more secure. Store the IP address of the client when the refresh token is issued. During refresh token validation, verify that the request is coming from the same IP address. This makes it more difficult for an attacker to use a stolen refresh token from a different location. Be careful with this as IP addresses may change. User agent binding similar to IP address binding. Store the user agent string, browser/application details, when the refresh token is issued. Verify the user agent during refresh token validation. Auditing log all refresh token related events, issuance, refresh, revocation, failed attempts, for auditing and security monitoring. CORS, cross-origin resource sharing. If your API and client application are on different domains, configure CORS properly to allow requests from your client's origin. In program.cs. Production secrets never store your JWT secret key or database connection strings directly in your code or app settings.json in production. Use environment variables, Azure Key Vault, or other secure configuration management techniques. Input validation validate all input, username, password, refresh token, to prevent injection attacks and other vulnerabilities. Error handling implement proper error handling and logging. Avoid exposing sensitive information in error messages. Rate limiting implement rate limiting on the authentication and refresh token endpoints to prevent brute force attacks. 9. Example client-side implementation, conceptual. This is a high-level overview of how the client-side code might look. This would typically be implemented in JavaScript, React, Angular, Vue.js, or in a native mobile application. Key client-side considerations secure storage store the access token and refresh token securely. Web browser consider using HTTP-only cookies or secure local storage with careful mitigation against XSS vulnerabilities. HTTP-only cookies are generally preferred for refresh tokens because they are not accessible to JavaScript. Native mobile use the platform's secure storage mechanisms, example keychain on iOS, key store on Android. Error handling handle errors gracefully, example redirect to the login page if the refresh token is invalid. Token refresh logic implement the logic to automatically refresh the access token when it expires. This is often done in an interceptor or middleware in the client-side framework. Token revocation, logout provide a way for the user to log out. This should revoke the refresh token on the server. Production hardening. The sample code provides a basic implementation of refresh tokens. A lot more goes into deploying a production-ready API. Here is an incomplete list of considerations when getting ready to deploy the API. Use a tool like Sonar Cloud to perform static code analysis. Set up logging for all the major events so you can find issues easier. Set up performance and health monitoring to make sure the API is behaving as expected. Set up an API gateway to protect the backend. Use a more robust secret manager. Create unit and integration tests. This comprehensive tutorial covers the essential aspects of implementing refresh tokens in a .NET 6 Web API. Remember to prioritize security best practices to protect your application and user data. This is a complex topic, and thorough testing is crucial. Good luck.